moving on to the key features of functions. Question 17 gives us the graph of the function b of x, and what we're trying to do is evaluate each of the following. b of 2. So what does this mean? Well, remember, any number inside the parentheses in function notation is always the x. The number we get out, that's the y value. So if we put in 2 for our x, what do we get out as the y? Maybe it's a little bit easier to see this written as a point. This is the point, let me just scooch it over a little bit more, the point 2 comma something. So the point 2 comma something has to lie on the graph. So let's mosey on over to when x is 2, which is right here. Hey, it actually is right on the x-axis. So this would be the point 2 comma 0 right here. Okay, that should be a filled in point. Let's see if I can get it filled in. It's a little better. Okay, so you will do this for the rest of these questions here for part A. Now for part B, things are a little different. They don't give us the x, they actually give us the y. So we now have the y value, -3, and we need to figure out the x. So what we're looking for is something comma -3. Sometimes this happens more than one time. Okay, so a couple of things that we could look at. Go to the graph. Okay, we go when y is -3, so we actually go down to -3. I don't see any points, or I don't see any part of my function right here. So what I have to do then is look left or right to see if it touches anywhere. Sometimes it touches more than once. In this case, it only touches in one place. So what are the coordinates of this point here? Well, those are the points -1, 2, 3, 4, 5, or the coordinates -5, -1, 2, 3. So -5 is our answer. X is equal to -5. One thing I'm just noticing up here, I forgot to write in that would actually equal 0. We're just taking this number here and writing it over there, just like how we wrote out x is equal to -5 down here. We'll do the same thing with b of x equaling 1. What I will tell you as a hint, that you should find 3 x values when b of x is equal to 1. So you should have x equals 3 numbers. Remember, the domain is left to right. So how far left did the graph begin to how far right does it go? We don't care about the up-down values. So think about how far left does it go to how far right it goes. The range is down to up. So how low does the graph go to how high does a graph go? Sometimes it's nice to actually write these off to the side. So I could even do something like that to help me with the range, and something like this to help me with the domain, and list off the low number here, how far down that went from the x-axis to how up it goes. Same with the left and the right for the domain. Remember, the maximum actually comes from the range. So whatever the highest point of the range is, that's the max, and whatever the lowest point was for the range is the minimum. Moving on to inequality and interval notation. Remember, whenever we see functions and we're dealing with, inputting numbers, it's always best to make a table. So input numbers to get numbers out. Make a table of this situation that's happening. We have the function x and f of x, and they gave us a range of numbers. In this case, the range of numbers deals with the domain. We're inputting 4, we can do 5, 6, but we stop at 7. And we're looking for the range. We're looking for all of the y values. So you can either graph the function, or you can do some substitution. So for example, -3 times 4, so we're just putting in 4 for our x value, and we're adding 1. Whatever that simplifies to goes here. Then repeat the same thing. Instead of the 4, we would put 5 in, get a new number out. And then it says in inequality notation. Remember, inequality notations will either deal with less than or equal to, and actually, we wouldn't even use greater than or equal to because we always want our numbers in order from left to right. So depending on whether or not a number is included or not, we're going to use those two symbols. 19 is very similar to 18, only they actually gave us a table, which is really great to see. So if we're looking for the domain and range, remember, in order to find both of these, we have to remember that we're going from low to high. Domain is x, range is y. So we're using that in our table. So the domain values from low to high would be 3 to 11. So here's the lowest x value, there's the highest x value. And it's an interval notation, so we don't have to do the same notation as we did in 18. So that just means put a comma in between them, and since they are both included, we will have closed brackets. Your range will look very similar to the domain. Only be very careful because this -3 here is not the lowest y. When you evaluate functions, it is very important to use parentheses. Again, remember, anytime you see a number inside that function notation, this is your x. So what this means is we're replacing x with -3. So f of -3 is equal to, instead of x squared, put it in parentheses, -3 squared plus, put it in parentheses, -3. Then you need to simplify. Here's one helpful tip. What is a -3 times a -3? A negative times a negative is not a negative. Be careful. 21 asks, is it a function? Well, we need to think what makes a function. Remember, a function is any time you put in an x value, you get a unique y value. So every x has only one y. You can't put in the x value of, let's say, for instance, 5 twice and get out 2 different y's. Then it wouldn't pass the vertical line test. It would actually cause 2 points to sit one on top of another. And we cannot have that happen. So they're asking a question. You have to pick one of these. Which one will make a function happen? So which one of these can we add that will let there be only one x go to one y? Make sure you use that function description to answer the question. So somewhere in there you need to say something along the lines of every x value has only one y value.